Technical Services for Williams. I am also the former Senior Vice President of Field Services for Laser Northeast Gathering Company. I'd like to thank you for your attendance tonight and your interest in the 4 plan approval applications that we have in front of us tonight. And I'd like to start with a brief background of Williams. Williams has been in business for more than 100 years, and it's one of the leading energy infrastructure companies in the country. Primarily, operations are focused on the Northeast, where we are today, the Marcellus Shale, Pacific Northwest, Rocky Mountains, Gulf Coast, and Canada. We have 3 offices in northeastern Pennsylvania. We employ about 70 people, the majority of whom are from this area. I'm pleased to say that I was thrilled to join Williams after they acquired Laser in mid-February. I've had a long history with Williams. I know they're an extremely reputable company, and they do a great job in building and operating infrastructure. This next slide is essentially an overview, a simple overview of the natural gas value chain. And that value chain is different depending on the type of gas that you handle. In northeastern Pennsylvania, we're lucky that it is very simple. As you see, you basically have your wellhead, which is considered your upstream or your exploration and production. That gas moves into a gathering system, which is what we operate. The gathering system is responsible for transporting and making that gas ready for delivery into a downstream pipeline or interstate pipeline. Some of the things that we do include dehydration of the gas, which is essentially just taking out water or water vapor, and compressing the gas so that it can meet the pressure requirements of the downstream pipelines. Then as you move into downstream, you have the natural gas end users. You know, we all know that the country is undergoing a total transformation in energy. We have an opportunity in front of us to use one of the cleanest burning fossil fuels there is in natural gas. Even though folks in Susquehanna County today maybe can't use natural gas in their home for heating, like a lot of the country does, you're benefiting from today's natural gas and low-price natural gas environment through the power that you use at your house. 30% of all electric generation comes from natural gas. You can see the rest of the numbers, but residential and commercial, a lot of that is space heating. Industrial applications use natural gas for a feedstock. So the price environment that we're in today benefits us all. You may not have it heating your house, but it is going to work its way through to you in other forms. Why do we need compressor stations? That's a good question. It's a question that we're often asked. The primary purpose of the compressor station is to make sure that the gas, as it is gathered in the field, can meet the pressure required to flow into the downstream pipeline. Today, we're currently delivering our gas into the Millennium Pipeline, which is in Broome County, New York. Millennium Pipeline is running anywhere between 1,000 and 1,100 pounds. What you will typically see in the field, even though you'll hear anecdotally how high the wellhead pressure is, producers don't like to and can't operate at those high wellhead pressures for very long. So we may be gathering gas at 400 or 500 pounds, but we need to get it up to 1,100 pounds to actually deliver it into those pipelines. And I guess hydraulically, an example that I like to tell people is that if you picture Interstate 81 and traffic going down Interstate 81 at 75 miles an hour, if you are natural gas and you're on the on-ramp and you want to get into that pipeline, you've got to be going 75 miles an hour or you can't get into that flow of traffic. And that's essentially what happens from a hydraulic standpoint with natural gas flowing at lower pressure. We need to compress it and we need to be able to deliver it in at the downstream pipeline pressures. A couple other things that we do at the station, as I mentioned before, we'll remove any water, whether it's free liquids or water vapor. We'll filter out any type of solid or particulate matter, whether it's sand or dust or grease or grime. And we'll also measure the natural gas through the station. This map is a map of the legacy laser pipeline. It's now called the Windsor line. What you can see is there's 10 miles of pipeline on the northern end. That's in New York. That's where our delivery into the Millennium Pipeline is. There's about 23 miles of pipeline through Susquehanna County, and we've got the 4 compressor stations that we have permit applications in today are shown in green, our Northeast Station, Snake Creek, Cane Road, and Lane Road. And folks will often ask, well, how do you locate these stations and why are they where they are proposed? And essentially, each one of these stations is going to serve as a central delivery point for an amount of gas that is being gathered behind it that the producers are drilling. So each one of these areas is going to have a lot of acreage dedicated to it that is being moved into these central delivery points so that we can compress it and actually deliver it into the pipeline to move into New York. Relevant components to the permit application, a couple of the emission sources. Compressor engines. Compressor engines are the devices that drive the compressors that actually compress the gas. In our case, these are typically Caterpillar 3600 or 3500 series compressors. Dehydration units. The dehydration units are the apparatus that will actually remove water vapor from the gas. And a produced water tank, that's the tank that once that water is taken out of the gas through various methods, that's where the water is delivered until it is trucked off-site to be processed. Some of the engine and site controls that we have on our stations, the compression and the related equipment, so the dehyds and the tanks, they're all monitored with very elaborate and sophisticated process logic controls, or PLC systems, that monitor operations. They help us ensure that the systems are operating at or below the permitted emission levels. There's literally hundreds of operating parameters that are monitored simultaneously 24/7. So these stations, they're going to be physically visited several times a day by our operating technicians, but they're also going to be watched 24/7. Every second somebody's going to have eyes on them. And some of the parameters that we look at are temperatures, pressures, differential pressures, things like that that will indicate to us how the equipment is operating, allow us to make decisions either as to whether or not we need to perform maintenance or do investigations, just to make sure that it is functioning as intended, which will help us meet and exceed all of our emission levels. Best available technology for the engines. You've got a couple of emissions that you're concerned about. First one is nitrogen oxide, or NOx. And one of the ways that you control NOx is through the use of an air-fuel ratio controller. What that controller allows you to do is run a lean fuel mixture. By running a lean fuel mixture, you're able to limit the amount of NOx that is produced from the engine. And the second thing that we use is called an oxidation catalyst. The oxidation catalyst on the engine, very similar to a catalytic converter on your car, is going to control your carbon monoxide, any volatile organic compounds, and formaldehyde. When you combust fuel, you're going to have these things, whether it's your car, your tractor, your combusting fuel, these are the results. So best available technology allows us to control these. This is a bar graph that in blue shows you what the emission level would be for 2 engines. Our permits all have 2 engines in them. So in blue, it shows you what the emissions levels would be without a catalyst. And in red, it shows you what they are after you use a catalyst. So NOx, because NOx is not typically affected by these lean burn engines, it's about the same. But when you look at carbon monoxide, it goes from over 90 tons to down in the low single digits. Volatile organic compounds, again, it cuts it more than in half. And formaldehyde, which is, I can't read it, HCHO, is almost reduced to nothing. Another question that we get quite a bit is, well, you want to put a compressor station in our area, what is it comparable to from an emission standpoint? So it's sometimes difficult because it's not always apples to apples. You can't just say it's this, and this on NOx and this on VOCs. But what we try to do is get things that are generally the same. A hospital, which is your first picture, is typically less than one of these stations. Something that is comparable is a truck, just a diesel truck. The emissions from a diesel truck are basically the same as one of these engines. A gas station is generally the same, though it gives off a different mixture of emissions and things.